to love this unit because it's like naming systems. So inorganic is the branch of chemistry that deals with metals and nonmetals bonding together. And it's very different from organic chemistry. Organic chemistry you'll learn your second or third year in college if you pursue anything related to science or medicine, or which is, I guess, science. So again, nomenclature, if you speak Spanish or German or English, you know nomen means name, and clature is just a system. It's a naming system. And everything we're going to do in this class is binary. Okay? Everything we do in this class is going to be binary. Now, does anybody know what binary means? Two, exactly. It's either like binary computers, or it's either a 0 or a 1. 0 or a 1. So binary is two things. Everything we're going to do in this class is binary. And this is important you remember this. Because you might see a chemical like our favorite compound, NaCl, and that's obviously two things. The sodium is plus and the chlorine is minus, NaCl is binary. However, you might see something like this. BaCl2, that's also binary. In this case, one positive and two chlorine, two negative things. Does that make sense? Now here's the one that trips a lot of people up. Eventually we're going to learn these things called polyatomic ions, and if you see something like this, NaNO3, you're like, oh, there's three things. What did Mr. Byers tell me on November 30th? Oh yeah, everything is binary. This can't be three things. And it's not. This is a polyatomic ion. Polyatomic ion meaning an ion made of more than one atom that sticks together and acts as one thing. This is the positive thing. This is the negative thing. Everything in this class is binary. So if you find yourself writing out more than two things, you're wrong. Okay? Everything's going to have one positive, one negative, or if there's two nonmetals, we'll get to that. But if it's a positive and negative, it's a metal, nonmetal, it can be one thing and another thing. Here's one of my favorite compounds. Whoa, what is that? This is not nitrogen oxide. What it is, it's a compound made of two polyatomic ions. This is ammonium nitrate. And we're going to learn about the polyatomics next week. So this, I'm sorry, what? It's really good for making explosives. It's one of the things you use to make AMPO, which you use to blow up buildings for, or if you're not a criminal, a mountain. You want to get that gold out, you blow a hole in the mountain. So anyway, so everything in this class is binary. If you find yourself writing more than two things, you're doing it wrong. Okay? Give me a thumbs up if you just paid attention to me and you understand this. So, how many things will be in every compound we're learning? Two. One positive, one negative. Okay. So, let's just go ahead. Now, I started using the chemical names. I've actually been using some chemical names all year, and I started using other chemical names just in the last few weeks. Our favorite chemical is this. This is sodium chloride. You know this is sodium chloride because you go buy it at the store and it says sodium chloride. It's not sodium chlorine. It's sodium chloride. What is this? Lithium bromide. Some of you have already started to realize the pattern. It's not lithium bromine, it's lithium bromide. What is this? Magnesium chloride. It's not dichloride for reasons that we'll talk about in a little bit, but it's magnesium chloride. And this is what? Magnesium oxide. Sodium chloride, lithium bromide, magnesium chloride, magnesium oxide. And some of you have already realized the pattern, and you've got a third of nomenclature already done. Now, when we name things, in almost every case, there's a couple of really annoying exceptions, but in almost every case, we're going to list the cation in the front and the anion secondly. The positive thing is going to be listed first. The negative thing is going to be listed last. And you probably already realized that the positive thing, the metal thing, doesn't have its name changed. The negative thing, The non-metal thing gets its name changed. You drop the last syllable or the last two syllables and replace it with "ide." Chlorine becomes chloride. Bromine becomes bromide. Oxygen becomes oxide. Does this idea make sense? You're like, whoa, new stuff. My head is burning. That burning you feel, that is learning. Okay, so give me a thumbs up if you're ready to look at this more in greater detail. All right, most of you are ready to go. Thumbs down if you want to go over it again. All right, here we go. So, we need to know right away if something is a metal and therefore a positive ion or a cation, or a non-metal and therefore an anion. So let's follow the little green dot to the periodic table. Boop. All right, so here's our metals, and here's our metals, and even down here some more metals. And here's our non-metals. There aren't very many of them. There are very few non-metals. So most of the periodic table is metals. This is all metals. Very few non-metals. So let's look at these and think, are these metals or non-metals? There's a big table right here. Okay, so magnesium, metal or non-metal? Metal. It's over there. It's in group 2. Will magnesium have its name changed? No. Iron, metal or non-metal?
Metal.
Metal. Name change?
Nope.
Nope. Fluorine, metal or non-metal?
Non-metal.
Non-metal. Fluorine will become?
Fluoride.
Excellent. Fluoride. Sulfur?
Non-metal.
Non-metal. Sulfur becomes
Sulfide.
sulfide. Sodium, metal or non-metal?
Metal.
Metal. Chlorine.
Non-metal.
Non-metal becomes chloride. Manganese? Right there at the top of the D block. Metal. Will manganese have its name changed? No. Calcium? Metal. Calcium's in group 2. You're like, but isn't it in milk? Yeah, but it's a metal. As an element, calcium's a metal. Remember at the beginning of the year I said this is calcium, and you're like, hey, it looks like a metal. So anyway, so calcium is a metal. Will it have its name changed? No. Aluminum, metal or non-metal? Metal. Name change? No. Nitrogen? Non-metal. Nitrogen just becomes nitride. Nitride. Oxygen? Non-metal becomes oxide. Chromium? Metal. Name change? No. Bromine? Non-metal. Bromine becomes bromide. Zinc? Metal. Carbon? Non-metal. Carbon will become carbide. Now, carbon is special because if you see carbon in the front, it doesn't get a name change. Because remember, carbon can be +4 or -4. If carbon's in the front, it doesn't get a name change. If carbon's in the back, it gets a name change. If carbon's a cation, no name change. Carbon gets an anion, name change. So let me show you what I mean. You could have the chemical actually, let's do something a little, Cl4. You've seen this before. Let's do one you've seen before. You could have the chemical Cl4, or you could have the chemical Na4C. This is carbon tetrachloride. This is sodium carbide. Can you see the difference?
Yes.
So carbon tetrachloride, sodium carbide. So if carbon's in the front, acts like a metal, it's positive, no name change. Carbon's in the back, acts like a non-metal, -4, name change. Camry?
So you don't put the beginning of the diet, etc. when it's in front.
Correct. We're going to talk about when we use prefixes in a little bit. Unfortunately, a lot of chemicals were discovered before there was an international group to name chemicals. What we are learning is called IUPAC. IUPAC.
And I don't remember what that stands for. It's something like International Universal Pack. Basically, International Universal Pack of Chemists. And what they do is they said, this is a system we're using from now on. That was in the 50s. Here we are 70 years later, and people still, you Google something that says dyes and tries where dyes and tries should not exist. And that's just because chemical companies are really, really slow to change. So you look at your vitamin bottle and you're like, oh, there's a bunch of chemical names that shouldn't be on here. Totally normal. Okay. Michael, do you have a question? Okay. So we're going to learn the IUPAC system, which is the proper naming system. Hopefully you guys can be the world changers. When you're out there in the pharmaceutical laboratories or you're making cosmetics for Max Factor, you'll be like, I'm going to use titanium dichloride. No, you're not. You're using titanium 2-chloride. We're not going to use that old system anymore. So anyway, getting back to this. We're not going to use the old system anymore. So cobalt is a metal, no name change. Silver? Nope. Boron? Nope. Lead? Nope. Potassium? Nope. Okay. Questions before we move on? All right. So binary compounds. Hopefully you're not writing anything down here because you already figured out. What is this?
Magnesium chloride.
Magnesium chloride. So the metals just drops down, doesn't have its name changed. The non-metal does have its name changed to chloride. Okay. So here are some common ions. I bet you know almost all of them. So let's just say them out loud. Oxygen becomes oxide. Hydrogen becomes hydride. Sulfur becomes sulfide. Chlorine becomes chloride. Fluorine becomes fluoride. Iodine becomes iodide. Very well, very well. Nitrogen becomes nitride. Thane's playing Jeopardy. Carbon becomes carbide. Bromine becomes, and the only really tricky one is phosphorus becomes phosphide. Okay. So there's your common ions. And that pretty much, that's all the elemental ions you're going to run into. There's not very many of them, just that little triangle over there. Okay. Later on, should you find yourself taking chemistry AP, you will find a situation where carbon, nitrogen, and sulfur will end up as a cation when they're bound to something more electronegative. Does that make sense? Remember, the electronegative thing is going to be on the right side. So if you have nitrogen and you bind it to fluorine, the fluorine is going to force the nitrogen to be a positive ion. Okay? Not in this class. But should you take chemistry AP, you will find that will pop up where like, nitrogen's in the front. Maybe a little bit in this class. Or nitrate, yeah. Okay, now, non-metal atoms. This is where you do use the prefix. You only use the prefix when you're looking at multiple non-metal atoms. Where are those, Mr. Byers? I'm glad you asked. They're right there in the corner. The carbon, phosphorus, selenium, iodine triangle, right there. So if you have multiple non-metal atoms, then you're going to use your prefix. You all know this. That nasty gas that everybody hates, but we're all producing it when we drive around in our cars, is that. What is that? This is carbon dioxide. And if your water heater isn't working properly and it's not producing heat properly, or your car is just sitting there idling and not getting enough oxygen, it's going to make something similar to carbon dioxide, but it's going to make that. What is this? Yep. This is carbon monoxide. And can you see the difference? Carbon dioxide, carbon monoxide. If you have glasses that are only on one side, what is it called? A monocle. You're a Bond villain. Mr. Bond. So you get monocle. Diacle? Okay. So we use a Latin-y prefix when we have multiple non-metal atoms. So if you have one anion, it's called Mon. If you have one nonmetal, it's called a mon. Hey, mon, there's only one oxygen. Carbon monoxide. If you have two, it's carbon dioxide. It's getting pretty cold to write your dicycle around, so enjoy it while you got it. But you can't call it a dike. You're just like, I'm going to ride my dike.
Yikes. Sorry, what?
Some of you are like, my innocent ears. If there is three, what's the prefix for three?
Try.
Tri. Okay. You can ride your trike all you want. You know. Boron trifluoride. Trigonoplanar. And you learned what the prefix for 4 was when you were playing your video games. What's 4?
Tetra.
Tetra. And 4 is tetra. So these are the ones you're going to see most often. Mon, di, tri, tetra. And I bet you already know what the prefix for 5 is. Penta. And sex? Sexa? No. Unfortunately, they use hexa instead. It would be fun, but you're like, somewhere along the line in geometry, they stopped calling the sexagon a hexagon. They started calling it a hexagon instead of a sexagon. Go figure. So, penta, hexa. 7 is interesting. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. You know our calendar is 2 months behind, right? Or 2 months ahead, depending how you look at it.
Yeah, because October is.
Yeah. October is the 10th, and November is the 11th, and December is the 12th. It's 2 months behind.
It's because of Caesar.
Yeah.
He put 2 months in there, August and July, and it really turned out wrong.
Yep. September became the 9th instead of the 7th. But anyway, so that's kind of fun. Julius Caesar, weirdo, but there you go. Okay, so penta, hexa, hepta, octa, nona, deca. Now, you could make a something carbon deck oxide. Now I say something carbon because if you have one nonmetal in the front, you don't start with mono. However, if you have 2 in the front, you do start with di. For instance, this is an actual chemical, N2O4. This is, guys, this is dinitrogen tetraoxide. Dinitrogen tetraoxide. And this is also an actual chemical. This is tetraphosphorus decaoxide. Tetraphosphorus decaoxide. Dinitrogen tetraoxide, tetraphosphorus decaoxide. Crazy. Yeah. Yeah, because it's not really an anion or cation. It's a non-metal covalently bonding. So if you have a non-metal, it's going to covalently bond to a non-metal. It's not really an ion. It's just a non-metal. Okay. Any other questions? Because magnesium is a metal. Excellent question. So the question was, why is MgCl2 not dichloride? And it's not because magnesium is a metal. If you have a metal, non-metal, you don't use a prefix. You only use a prefix when you have a non-metal, non-metal. Okay? Any other questions? Thumbs up if you're ready to practice. Thumbs down if you want to go over it again. All right, practicing. Here we go. All right, so I'm going to turn the lights on. There are 12 things to practice. Go ahead and give yourself 10 minutes. I'll choose some military volunteers. You never start with mon.
I feel so alive. That sodium, sodium chloride. Why are you skipping around? No, that's
Yeah.
no, it's try.
Beginning when it's by itself, do you still need the mono?
No, you never need a mono when it starts with just one. So carbon monoxide, carbon dioxide. You don't need a mono. You only need a mono if there's 2 or 3 or more of the first thing. So, I'm sorry, you only need a mono when it's the second thing. You'll never start with a mono. But you might need a di or tri in the beginning. I'll come over here.
Carbon.
We only use mono like when it's like a metal, when a non-metal and a non-metal bond, that's what it use mono on the second part.
Right.
So if it's like lithium and chlorine, it would, you wouldn't use the mono.
Correct.
Okay, so carbon is a non-metal?
Carbon in the front is going to act as a metal, although it's not really a metal. It's going to act as a cation. Carbon in the back will act as a nonmetal unless it's also bound to a nonmetal.
But is it a non-metal?
Yes.
Okay, so that's why that's a carbon monoxide.
Yes. Oh, 1 second.
So for H2O, do you want us to put water? Do you want us to put
BR?
dihydrogen oxide?
Dihydrogen monoxide. Yeah.
Does hydrogen act as a non-metal?
Yes.
Didn't say that. I'm going down like this. 1, 2, 3, 4. I'm at 5. P2O5. Topic of nitrogen monoxide. Oh, that one? Never mind. Or nitrogen monoxide. Oh, I wasn't
That is nitrogen.
Oh, H2O water.
Not water.
Dihydrogen oxide.
Close. You're 4 letters right. By the way, a lot of times we'll skip the last syllable of mono. We'll just say mon instead. So, and tetra sometimes gets its A skipped too. But if you say monoxide, no one's going to care. If you say monoxide, great. If you say monoxide, that's okay. Penta. It's like a pentagon, and a hexagon, and a heptagon, and an octagon, and a nonagon, and the decagon, and a dodecagon, which is 12. I'm sorry, what? Well, there's a very good chance. All right. Are we ready to come back to order? No? You need one more minute? All right.